In this video, we are going to see how to create built-up sections in SOFiSTiK. This is SOFiSTiK Structural Desktop. We have project navigation tree over here, and we can define the cross sections by right-clicking on cross sections and going for new standard section, steel profile. You can select the choice of your material. You can give a title of your own. If you want to use any other standard than European, then you can check on this box. Change the shape of the profile from here. Let's take an example of a double L section. So I've selected L. You can select the type over here, IS 808. And then you can talk about or give the dimensions for your legs. You can go ahead with 100 by 100, say for example, with a thickness of 8 mm. The calculation method here is solid, but you can also keep it thin walled. And the mode of the profile is full. You can also make it half, but we want it full. Alright, so here we have mode of profile as full. Let's understand how to make built-up sections so that everything comes here in the geometry. The reference point of the profile is important to specify over here because we want to provide symmetric option based on the reference. So we are going to firstly select the symmetry options. If there are two L sections, double L section, then select any of these on Y, on Z. If you want 4 L sections, then you can make it on all axes. So I'm going to go ahead and select on Z axis for example. Okay, and now we can see two L sections, they are overlapped, so we need to specify the reference point, and that's why I'm going to go ahead and select let's say top center over here, or you can make it top positive. Now they're sticking to each other. If you want a gap between them, you can specify the coordinates of the reference point. So if I say 10 mm in this way, so now there is a gap of 10 mm on each side, so it's 20 mm basically. Alright, if you go ahead with 5 mm, then there's a gap of 10 mm total. Okay, so this is how I have specified. You can make it bottom positive as well. This is also a way, or you can make it at the center. So that is also possible, in which case you have to, of course, modify the reference point accordingly. Okay, so this is how you can make built-up sections using the SOFiSTiK cross sections, standard sections option. You can also make a customized cross section using this checkbox on option. And that is it. Let's click on OK, and we are done over here with the double L section. Okay. Now let's understand about built-up sections, the regular kind of cross sections, not standard sections. So for that, we have to right click on cross sections over here, and we can either go for new solid section or new thin walled section, and then we'll select steel from here. See over here in SOFiSTiK, basically the SOFiSTiK will open, and the dialog box for section property definition, cross section definition will open. You can give a name over here as steel built up or any of your choice, of course, and click OK. Once you click OK, you can go ahead and model thin walled cross section element. So I'm going to select thin walled cross section element from here. I'll give a thickness of 8 mm, and I'll start drawing. I can start my drawing from with this 0, and I'll make 100 mm from here, and I'll repeat the process. This is in 8 mm. Basically I'm just drawing the cross section. I'll use simple AutoCAD commands like mirror, and I'll mirror it. Now you have to of course take the correct plane and then mirror it. Alright, let me just make a simple line between these two so that I place my cross section. I'm using move command and place my cross sections at the center. Okay, so this line actually has nothing to do with the cross section, it's just for moving at the right location. Alright, so here I have got my built up steel section. All I have to do now is click on calculate. Now once you click on calculate, you might get a warning which can be turned off. So you can simply now close this, save. Alright, let's go ahead and create a structural line. I'm going to select eccentric beam. If there is a centric beam, you do not want to consider any eccentricity, then you can click on centric beam. So I want to consider eccentricity, so I'm using the eccentric beam option and I will select my steel built up. You can provide the maximum length, let's say 1 meter, and I'll select objects, so you can use pick lines or curves. I'm going to select objects, select the line that I already have and right click. I'll press escape and now you can see over here we have the double L section applied to an element. Okay, now I'll simply go ahead and export this model to SSD for further analysis. I'll click OK. There will be warnings, the same warning which we had received while we clicked on calculate. Let's go to SSD. Here, if you want to remove the warning, then you can right click on cross sections, go to the text editor and use the command control warn 321. This will help to turn off the warning. I'm going to perform linear analysis with the self weight of the structure and I'll click OK. So the analysis is done, but so we have the loads. You can actually see the self weight and you can also look at the results. Like let's take a look at the support first. Let's increase the size of our font and then we have beam elements, forces, and you can see the shear force over here. If you want to take a look at all section locations, then you can go to the line and use beam sections and click OK so that you can see the output for each element division. This is VZ. You can also take a look at bending moment. So we have it all properly available with us. There is no problem in the analysis even if there is a warning given by the program. So that warning was actually for the shear, which will be considered during the design. We are just performing the analysis here and that's why there is no issue. So that is it. Thank you very much. If you have any questions, please write back to us.